Hello, Algebra 2 students. Today we will do 1.5 and 1.6 notes. In 1.5, we will use problem-solving strategies and models to solve equations. And in 1.6, we will solve linear inequalities. A verbal model is an equation written in words. Let's do some examples. Example 1. The driving distance between Boston, Massachusetts and Cleveland, Ohio is about 660 miles. So the distance is about 660 miles. If you drive this trip in a total of 12.5 hours, so that's the time it takes to travel 660 miles, what is your average speed? So the question is, what is your rate of speed? So in this particular problem, we are going to use our DIRT formula. So distance equals rate times time. And then we are just going to substitute the variables that we do know. We know the distance is 660 miles. We don't know the rate of speed, but we do know that the time is 12.5. So we are going to multiply the right side, so that's 660 equals 12.5 times r. And then our last step to get r by itself is divide both sides by 12.5. I used a calculator and I got 660 divided by 12.5 was 52.8. And so our answer in correct units is 52.8 miles per hour. Okay. Example number 2. The table shows the number of seats in each of the first 4 rows of an auditorium. The remaining 10 rows follow the same pattern. Find the number of seats in the last row of the auditorium. So if we did 10 more rows after this, we could make a table, but we don't want to do that because what if the question asks, what about 50 rows? So we want to find a pattern between X and Y. So the thing we need to notice here is what's the information in the table. So we have the first 4 rows. In row 1, there's 12 seats. Row 2, there's 14, and so on. So notice each of the rows is going up by 1. And each of the number of seats in each of the rows is going up by 2. So plot positive 2 because there's an increase. Here's where students make mistakes. And we need to know that the row is your X and the top row is X and the bottom row is Y. That's usually how tables are. We really need to know how many would be in the 0th row. Now the 0th row doesn't make sense, but if you were to go backwards, so you want to make a little spot here for the 0th row. And since you know the seats are increasing by 2, then you know in the 0th row there'd be 10 seats. And that number right here is what is known as your y-intercept. And you find it when x equals 0. So notice the top number is 0. And so the y-intercept is 10. And the y-intercept in algebra is b. So b equals 10. And the other thing we want to do is we need to find the slope. So how do we figure out the slope? So the y-intercept is b, we need to know m. So we are going to use this equation, which we'll use again in chapter 2, and you've all seen it, is the slope-intercept form. So m is your slope, and b is your y-intercept. Which I just mentioned what it was. So in this particular case, to figure out the slope is the change in x change in y, sorry, divided by the change in x. So the change in y is going up by 2, and x is going up by 1. 2 divided by 1 is 2. So your slope is 2. So now that we know that m equals 2 and b equals 10, we can write our equation. So our equation is y equals 2x plus 10. The last number is always your y-intercept. And if we wanted to use real life variables where we called s as the number of seats and r as the number of rows, we could use s equals 2r plus 10. Totally up to you whether you want to use real life variables or if you want to stick to standard x and y. Now let's answer the second part of the question. Find the number of seats in the last row of the auditorium. I guess we didn't even need to write the equation, but we needed the equation to find the number of seats in the last row. So notice there were 10 more rows after the first 4 rows, so that would be the 14th row. So S equals 2 times 14 plus 10. So that's 28 plus 10. So there's 38 seats in the 14th row. Not 38 altogether, but just in that row. There we go. Okay, the last one's a little difficult, but that's okay. You know, we can work our way through it. Your long-distance telephone plan charges 8 cents per minute for weekday daytime calls and 5 cents per minute for night and weekend calls. If you made a total of 220 minutes of long-distance calls during one billing cycle and your bill was $13.16, not including taxes and fees, how many minutes of the night and weekend calls did you make? So this is a little tough, but you know your total bill is $13.16. Let's assume there are no taxes as stated in the problem. We don't know, we know the total number of minutes is 220, but we don't know, say, the daytime, how many daytime minutes there were. But we do know that daytime calls were 8 cents a minute. So we can let D be daytime calls. Okay. So each daytime call is 8 cents a minute. And so 8 cents in dollars and cents is 0.08 times D, because per each minute, plus we also have nights and weekends. Nights and weekends are 5 cents per minute, so that'd be 0.05. Here's the hard part. We can't use two variables. You don't know, we're not supposed to do that yet. So how can we use the same variable D in this problem? And we also know that the total is $13.16. Well, if you know there's 220 total minutes, you are going to have to subtract the number of daytime minutes from 220 to get the number of nighttime minutes. And that's all we do. So 220 minus D represents the nights and weekend minutes. And then D just represents the daytime. And now you have the equation, you can solve it. So 0.08D plus, distribute here, 0.05 times 220, and then 0.05 times negative 1D. So that 0.05 times 220 is 11. I used my calculator. Minus 0.05D equals $13.16. I'm going to combine the 0.08 minus the 0.05D. So combine those two because they're alike. Notice the sign in front. Oops. Okay, so that is 0.03D plus 11 equals 13.16. Subtract 11 on both sides. Put zeros there if you need to. You have 0.03D equals 2.16. I thought I did something wrong, but I have not. So let's figure out this. And now we want to divide both sides by 0.03. D equals 72. And the question is, how many minutes of the night and weekend calls did you make? So that's daytime. So 220 minus 72 gives us the nighttime. So I'm going to subtract. So it's 148. So 148 night and weekends. And that's what we do in section 1.5. Okay, now going to section 1.6, we're going to talk about linear inequalities. A linear inequality is an inequality with an equation of a line. A linear inequality uses less than, greater than, less than or equal to, and greater than or equal to. So hopefully memories of Algebra 1. When we're graphing linear inequalities, for less than or greater than, we use an open circle to graph on the number line. For anything less than or equal to or greater than or equal to, so greater than or equal to or less than or equal to, you're going to use a solid, a closed circle. And so just remember, a line underneath the inequality means you use a closed circle. Your goal is to make sure the variable is on the left side. So make sure variable is on the left. If you do, then you can follow the arrow in graphing. I'll show you. Okay, so this is a good goal to have. So if you look at example 1a, notice x is on the left side. Graph x is greater than -3. And if you look, this is basically an arrow, because you can just draw a little line. The arrow is pointing to the right. So I'm going to erase that just because I don't like it there. It gets a little cluttered. But the arrow is pointing to the right. So what you're going to do is you're going to put an open circle, because the greater than does not have a line underneath, and you're going to shade to the right. So there's your graph. For B, notice x is on the left side. This time it's less than or equal to. So find 0 on the number line and put a closed circle. And notice the arrow is pointing to the left. Just draw a line, just making an arrow just to help you. And we're done. Okay, for example 2, this is an example, or 2a is an example of an and inequality. An and inequality is what is known as a compound inequality. Both of these are A and B. But with an and inequality, you have a sandwich graph. So if you look over here, you would want a closed circle at -2, because there's -2 is less than or equal to x, and x is less than 3. So that's how you say it. There's not a word and, but you would say it that way. And then you would put an open circle at 3. And then this is your graph, just sandwiched. And the two endpoints are your boundary points. In B, B is definitely an or graph. You see the word or in it. And it's also a compound inequality. Compound just uses the word and or, just like it's compound sentences in English. And for the first one, and notice the variable is on the left side, which is excellent. If it's not on the left side, just rearrange it, flip everything. So x is less than -1. So the arrow, it's an open circle at -1. Arrow is pointing to the left. And then with greater than or equal to 1, it's a closed circle, and arrow is pointing to the right. These are examples of rays because they're pointing in opposite directions. So the graphs point in opposite directions, whereas the and is a sandwich. Okay, examples 3 and 4, we're solving a compound inequality, and then we're going to graph. Notice example 3 is an and because there's no word or. So solve -10 is less than 3x plus 5, which is less than or equal to 8, or and less than or equal to 8. Then graph the solution. So I'm going to write the inequality. -10 is less than 3x plus 5, and 3x plus 5 is less than or equal to 8. So you do these the same way you would do equations, but you have 3 sides. So your goal is to get x in the middle for your sandwich. So the first thing you want to do is subtract 5 on each side. And notice there's 3 sides. The biggest mistake you can make is not remembering that there are 3 sides. Okay? And that'll give you -10 minus 5 is -15, is less than 3x, is less than or equal to 3. And our last step is divide everything by 3. And so our answer is -5 is less than x, and x is less or equal to 1. So you can write this as -5 is less than x, and x is less than or equal to 1. And we don't like the graph to look like that. We like to have the x on the left side. So just make sure the inequality is also facing the same direction once you flip it. So graphing this, x is greater than -5. So open circle here and close circle there. So greater than -5 means arrow goes to the right, and less than or equal to 1 means arrow goes to the left, and eventually they meet up right like that. And that is your answer. So you can write your answer like this, or either one of these ways. And example 4. This is an or compound inequality that we're going to solve. So you solve each basically separately and then graph. So we have 2x minus 1 is less or equal to -7, or 4x plus 3 is greater than or equal to 7. Just remember there's no equal sign, but you treat it like solving an equation. So add 1. 2x is less than or equal to -6. Divide by 2. Kids just accidentally put equal signs there, and it's kind of hard not to because we're used to it. X is less than or equal to -3. And we can graph that particular one before we even do the second inequality. So the variable's on the left side, and close circle at -3, and notice the arrows pointing to the left. Okay, and now let's do the second inequality. Subtract 3. 4x is greater than or equal to 4. Divide by 4. X is greater than or equal to 1. Now this is not your answer. It's not correct unless you put an or there. Big difference. In example 3, if you wrote it like this, you don't have to put the word and, but if you broke it up, then you'd have to write the word and. Okay, so there'd be a closed circle at 1, and the arrow is pointing to the right. All right, there's one thing I want to make note of that's not on this, on the notes is, and students forget this all the time, so you need to put this in your notes somewhere. So you need to reverse or flip, means the same thing, your inequality when you multiply or divide by a negative number. So reverse or flip your inequality when you multiply or divide by a negative number. It has to be a negative number. So here's an example. We have negative 4x plus 3 is greater than or equal to negative 17. So what we want to do is we want to subtract 3 on both sides. So that's negative 4x is greater than or equal to negative 20. Divide both sides by negative 4. So look what I just said. Divide both sides by negative 4. It doesn't matter that negative 20 is negative. It could have been positive, but you're dividing both sides by negative 4. So you instantly flip your inequality. You don't change any, you didn't divide regularly. Negative 4 by divide by negative 4 is a positive. It's a positive x, and that's 5. And that would be your answer. And then, of course, you would graph it if it asked you to graph it. So just make sure it works for multiplying. So it would work in this case too. If you had something like negative 2/3 is less than 4, you would multiply both sides by the reciprocal of negative 2/3, which would be 3 over negative 2. And so the 3's cancel, the 2's cancel, but because you multiplied by negative, you have to flip your inequality. Oops, I forgot my variable. So it'd be x is greater than 12 over negative 2.